Hello guys, this is Rage Game Dev, and welcome to another episode of Let's Build a Platformer in Love2d. So today I got a lot planned. I plan on working on a camera and also a object thing. I believe we already have a hierarchy. Yeah, we got some objects here. We're gonna work on the player then, and also object manager. So kicking things off, I just want to talk a little bit about this series. Also, I just want to point out one thing. I made a slight change. So if you remember, this looked like this part right here looked like this. And if we build and run this, this top thing was cut off. Now, I'm not really sure what that is, so I'm just going to, if you just take that out, it will draw the whole thing, because the map's a square, it's not a rectangle. If you want to support rectangles in the future, I will have to do some editing, find out why that's like that. But anyway, going back to things, I'm going to create in Tools, I'm going to create a new file, name it camera. So okay, so about the series, I really want to make it a little bit more, I don't know, relaxed. Like I've kind of made it so it's like a step-by-step process. You know, first we do this, first we do that. But the series is really about how I make games, and when I make games, there's a lot of trial and error, and that's not how I make things. So I'm gonna try showing you more of the process of how I debug and all that other crap. So right now I'm just creating a simple camera module. Just creating a table. I'm gonna make a position for the position variable or vector for what am I doing for the camera? Yeah. So I'm just gonna put it at 0, 0. I'm also gonna add a size. So if you're gonna have a bunch of vectors or anything, then I would definitely make a local require for it. But right now I'm just making 2 of them, so it's not really a big deal. So okay, so some functions for the camera. We're gonna need to set the camera and then unset the camera. So everything within this camera colon set will be transitioned around according to the camera's position. So how the camera works is we're going to be popping the graphics, translating the graphics, then pushing it to the graphics card. So that we're basically moving the entire scene around, and yeah, it'll give the illusion of, of movement. So we're going to create a couple localized functions just because we're going to be calling the set function every frame. And if you're ever going to call something every frame, then make sure you localize the global functions because it speeds it up. So we're gonna add a pop function, lg.pop. We're gonna add a translate function. So trans is equal to lg.translate. A rotate function, which is lg.rotate, I believe. Oh, that's another thing we need to add, rotation. I'm going to just put it at 0. And I believe that's in radians. So if you're going to work in degrees, you should use the math.rad function or math.degree function. Then we're going to scale. So let's say lg.scale. And next, push. So yeah, it's just going to make it faster for us to type. It's going to make it faster for Lua to, I don't know, just run. Because localized function or localized anything, local variables perform a lot faster because Lua doesn't have to look through as many hierarchies and trees and all that as it does in a global function. So in the set right here, we're going to say translate. We're going to say negative self.position.x and negative self.position position.y. Now the reason why we're using negative is if you think about it, when the player moves forward, then the camera needs to move backwards. So basically just like the entire world will move backwards in the opposite direction of the player. I hope that makes sense. You'll see once we have a visualization of it. We're going to rotate by saying self.rotation, self.rot actually. We're going to scale by saying let's add another vector. So I'm just going to copy this and then paste it here. I'm going to name this scale. And instead of setting it to 0, 0, I'm actually going to initialize it at 1, 1. And I believe this. Okay, let me check something real quick. Yeah, you can see, I just made a video on like a speed draw video. So I'm gonna check the camera in here because I have a camera. Let's see. Okay, so first actually I need to push it, huh? Scale, yeah, that's what I thought. Okay, so negative self.rotation, self.scale dot x, 1 divided by self.scale dot x. And we'll do the same thing for y. 1 divided by self.scale dot y. Alright, next in the unset, all we have to do is call the pop function. And that's our basic camera right there. So if we go into the main, and we require a camera. Now I made it a global module just to make things easy. Using a well, actually you should localize it, but for now I'm just gonna make it global because we're only gonna be using it in the main. Yeah, that's what I like to do while I program is get it to a working state, even though it's not the most efficient. At least get it working, and then you can always come back and change things around. So if we run this, a value push and it'll value. Okay, let me check. What's up? Well, we don't have a whoops. That's supposed to be an S. Alright, let's try this again. Okay, so everything looks exactly the same. Nothing should have changed. So I'm gonna make a helper variable. It's gonna be a global, so I'm gonna say game time, make it equal to 0. And this will be useful. We're just gonna say game time is equal to game time. This will be useful for many things, not game loop. Game time. I might actually add this to the game loop. Anyway, so it increments by dt, and we can use this for sine waves and creating a bunch of other stuff. So we're going to test the positioning of the camera. So we're going to say camera.pose.x is equal to camera.position.x plus math.cosine of game time. I'm going to divide that by, I think, 5 would be good. Let's see. Yeah, anyway, so now you're seeing one big issue right here. You're seeing tearing, and we can fix that really easily. So to fix that, we're going to go over to our tile manager. Up here, we're going to say self.image.setFilter, and we're going to say nearest neighbor. Actually, before I do that, I want to zoom into the. I'm going to use the camera to zoom in, and then you can see why I do that. I'm gonna multiply this 10 to make everything faster. Ooh, is it gonna come back? Doesn't look like it. Multiply by 2, divide by 10, maybe. Just play around with these. This really isn't important. I don't know why I'm messing around with this. But yeah, it should go back and forth, just like a sine wave. Anyway, so I'm gonna zoom in. So I'm gonna do the same thing with the camera zoom. So camera.scale dot x is equal to camera.scale. Well, let's just do this actually, just make things easier. Up here, I'm gonna say camera.scale dot x is equal to 0.5. Actually, this is zoom in, and let's do the exact same thing for the. Whoops. Same thing for. Wow, I cannot. I'm getting these key bindings wrong for the y, and I'm actually gonna say 0.2. So we're gonna really zoom in, so you can see the issue that I have. Let's move the camera down. Say 256, and should we see a tile? Stop moving. Oh man. Okay, we're just gonna go 0.5. Having some issues here. There we go. Anyway, so as you can see, there's these weird lines in between. You can see that the graphics are really fuzzy. It's all ugly. I hate that. So the reason why there's lines is because OpenGL likes to oversample on its images when you don't have perfect integers. If it's a floating point variable, then it will oversample. So yeah. Anyway, kind of complicated stuff. but let's close this. Let's go over to the tile manager. To fix this, we're going to add nearest neighbor rendering. What this will do is it won't make it smooth. It'll render it to the nearest pixel. So look really awesome. As you can see each pixel, and if we do a camera zoom thing, it's just gonna look really cool. So scale, let's see what happens here. Whoa, yeah, that was not right. Whatever, anyway, we don't have to do that. Dang, there's a lot of cool things you can do with the camera. Anyway, we have a camera. It works. It moves side to side. It's still scale. So next, let's get started on an object manager. So yeah, we got a camera. So what an object manager will do, it will store all the objects that we create in our game, like boxes, like players, enemies, swords, whatever. It's going to store it in a really long table that we can iterate through and delete certain things and just manage all the objects, making sure they all work. We don't have any weird null variables and all that. So let's create a object manager module. So I'm going to name this obm.lua. Inside here, I'm going to make a local obm, make it equal to table, and return it. So obm stands for object manager, if you're wondering. So function obm.load, and we're also going to add it to the game loop. So let's say obm.tick, pass in dt. And then we're also going to have another function down here called obm add. So whenever we create a table, or not table, but an object, we'll add it to the object manager. Up here, we're going to say self.objects is equal to a table in the tick function, and we're also going to add it to the game loop. So let's say game loop add loop self. In here, we're going to loop through all the objects backwards. So for I is equal to number self. Whoopsie. There we go. Self.objects. Go to index 1 and go backwards -1 step. So we're going to say local obj is equal to self.objects I. I'm going to add a variable to the entity. So in here, we're going to say entity.remove. So there might be some destroy functions that we'll add to, let's make this false, to the entity, like to clean up files, and like we might add volume. I'm not really sure. I'm more basing this off the games I create in Chrome SDK, because you do have to do a lot of cleanup in that game. In that thing, we have to clean up the graphics, make sure to put them to null, or else you're gonna get memory leaks. But in Chrome SDK, you don't have to worry about it as much. But I'm still gonna add it just to be safe. So we're going to say if obj dot remove, then we're going to remove it from the table. If it's equal to true, then we're going to move it from the objects table. So we're going to say table dot remove self dot objects. That's the table we want to remove from, and then we want to remove index I. And yeah, there we go. We might want to break. No, we're fine. In here, in the obm add, I'm actually gonna, well, no, it's fine. We're gonna say table.insert self.objects, and we're gonna insert the object obj. Up here, I'm gonna actually initialize the object. So I'm gonna make, I think I named it load. Did I? Yeah, I did. So we're gonna call the load function so that I can create graphics, variables that needs and all that. So yeah, it's a really simple module, the OBM. We're gonna add more complicated stuff later. So up here, let's say OBM is equal to require tools OBM. I believe I put it in the tools. Did I? Yeah, I did. Okay, good. I'm gonna put OBM after the tile manager, and we can change this around later. So we're loading it, and let's just see if there's any errors, and there's not. Good. Next thing, I'm just going to add a quick player module. I'm not going to add a lot of physics in this video. In next video, I will add player collisions and simple physics and all that. So let's just make player.lua. We're going to extend from the entity class. So let's say entity. Well, let's actually just do this. Local player is equal to require Quiet. Oh my word. Make it a table. Return player. I'm having a lot of troubles today. I'm gonna capitalize this too. So player, capitalize, capitalize. I'm gonna say function, player, new. And we're just gonna have an x and y coordinate for where to position the player. We're gonna say local player not capitalized is equal to require objects / entity. I'm gonna say new. Now I can't really remember what I'm putting in here. All right, there we go. All right, I see. So I'm just gonna put this in a comment. Actually, before we make this player class completely flesh it out and everything, get ready for physics, I'm gonna add one more module, and then I'm gonna actually end the video. So this is where we're gonna end the player class, and we'll change things around. I'm actually gonna even just comment this out so we can build the game without errors. Okay, so the module I'm gonna add is gonna be a asset manager. So from all our objects, we're gonna be wanting to access, different images to sample from with a quad and all that. And to be able to do that, we want to have them in a table that we can just instantly grab the image that we want, and also manage it so we can clean up the images, and not just images, but all assets like shaders, audio, and anything that's basically an asset. So I'm gonna put it in the tools again. I'm gonna name it ASM for Asset Manager. I'm gonna just say local ASM is equal to a table, and then return it. It's actually gonna be a lot like the Object Manager, except without the update function. ASM dot load. Gonna make a table of assets, so self dot assets is equal to a table. And then I'm gonna make an add function. Oh, and a get function. So ASM add asset. Gotta be careful when I type here. I'm gonna say I'm gonna create a local table, name it A. I'm gonna say in the table I'm gonna make a variable called asset. I'm gonna make it equal to asset, and I'm gonna make it so you can grab the asset by its ID. So I'm gonna say ID is equal to ID right here. So we create a local object with the asset and with an ID. Then we're gonna insert it into the table. So table insert. The table we want to insert into is self.assets. We want to insert A. So in the grab function, or asm.get, we're going to get it by just passing in a identifier. So let's loop through all the assets that we have. Actually, I'm just going to use the I-pairs loop. A, I, in I pairs, because we're probably not going to do this every single frame. Self.assets. Actually, I'm going to swap this around. There we go. So we're going to say if a.id is equal to id, then return a.asset. So, okay, so we loop through all the assets. We grab the object A. If the A ID is equal to the ID that we passed in there, then we're going to return the asset. So if that's image, whatever we need. So we're going to create we're actually going to test this out right now. So up here, the very top, let's actually create a local or global ASM. It's equal to require tools ASM. Here we're going to say ASM.add. Now, if you remember back in the tile manager, we have the image right here created. But let's say we want to use this tile image somewhere else, then it's only specifically the tile manager, and it's just a pain. We're going to create the ID of tiles. So we just ask in the image that we want to create, give it an ID. Over in the TLM, we're going to say asm.get. We want to get the tiles image, so I'm going to say tiles. Now, if all goes according to plan, this should work. Of course, it doesn't. Okay, I need to add a do. Yeah. Make sure you add your do. Bad argument, insert table expected got null. We need to call the load function, of course. ASM colon load. most when you're debugging, almost all the things you do when you debug is things that you just forgot, like you left out. Anyway, so yeah, it worked. It grabbed the image, and now I can pull quads from it. And yeah. Anyway, that's gonna end it for us today. In the next episode, we're gonna work on our player. We're gonna create this awesome, player. We're gonna use really cool physics. We're not gonna be using Box2D. I want to use my own physics engine, just because Box2D I feel is it's a little bit heavy for a platformer like this, because it's actually not that hard to do yourself. Anyway, thanks for watching, and I'll be back in the next episode. Peace out.